This is Unit 3, Moles and Stoichiometry, Lesson 7, Naming and Formula Writing for Binary Compounds. How do we name and write formulas for binary compounds? By the end of this video, you will be able to identify binary compounds by name, and you will be able to construct chemical formulas for binary compounds. So review due now. Recall from our last unit that elements cannot be broken down by physical or chemical changes. Compounds are composed of two or more elements that can be broken down by chemical changes. And recall what type of matter can be broken down by physical changes. Hopefully you said mixture. So ions are elements with a charge. The reference table lists these charges for each element. If the element is positive, it is called a cation. If cations are named the same as the element, for example, a calcium atom, if I create an ion, a charged particle, it will be a calcium ion. This +2 tells me it is an ion. If the element is negative, this should say is negative, it is called an anion. Anions are named ending with IDE. So for example, a nitrogen atom, if I create a nitride ion, notice I've changed the ending of nitrogen to IDE and named it as an ion. So here are some examples. If it's positive, it's a cation. So these first two are cations, and this will be a magnesium ion, and this will be a potassium ion. If it's negative, it's going to be an anion. So these next two are anions. So this is going to be an oxide. Recall with an ion, we're going to end with IDE. This is fluoride ion. Here's a cation, so it's going to be lithium ion. And this is an anion, so therefore it will be an iodide ion. So the next slide gives those words listed out, so you can write them down. Binary compounds consist of only two elements. For example, sodium and chloride. Sodium chloride. To name binary compounds, we're going to write the complete name of the first element. The second element should then be named using the first syllable with the ending "ide." So sodium is our first element. Chlorine is our second element, so we're going to change the ending to "ide." Sodium chloride. Ki, potassium, is our first element. Iodine is our second element, so we'll change the ending of iodide, so it will be iodide. Magnesium is our first element. Chlorine is our second element. Even though we have two, we're still just talking about the two elements. Chlorine will change to chloride, so magnesium chloride. Calcium is our first element. Nitrogen is our second element, so we'll change the ending to nitride. Calcium nitride. So try these examples on your own and check your work. Okay, writing chemical formulas. The sum of the charges or the oxidation numbers in a compound is always equal to 0. So for example, sodium has an oxidation state of +1. Chlorine has an oxidation state of -1. So a +1 plus a -1 is going to equal 0. So writing formulas, we're going to write each ion separately with their charges, first thing. Then we're going to do second, our crisscross and reduce rule. So we're going to crisscross the charges, not the signs. Write those numbers as subscripts and do not write the ones. So these are your rules for writing formulas. So let's do an example. So we have a compound containing magnesium and chlorine. So you'll need your reference table out. We're going to first write the ion symbol for magnesium. So magnesium is a +2. Chlorine is a -1. So I'm going to drop the signs. So I scribble them out, and then we're going to cross, and we'll write Mg. The 1 has come down. We don't write it. Cl2. We crossed our sign. Check your work. Example 2, a compound containing barium and oxygen. So we need to look on our reference table. Barium is Ba, and it is also a +2. Oxygen is O, and it is a -2. We're going to drop our signs and then cross. So we'll have a Ba2 and an O2. And then we'll call the second part of the crisscross and reduce. So we will reduce these because both 2's can be divided by 2, our common reduction. So BaO. We're never going to write it like this. We're always going to reduce it. So check your understanding. You can now identify binary compounds by name, and you can construct chemical formulas for binary compounds.